Section 9.7, Systems of Linear Inequalities. So what we've been solving have been linear equations, and that's simply statements with equal signs. All right. So inequalities are statements with either less than or greater than. Now we can have less than or greater than, less than or equal to, greater than or equal to, or we can have just less than and greater than. What that indicates is everything up to that line, but not passing that line. If you say less than or equal to, you're going to include that line in your solution. That means everything on that line will also make this statement a true statement. So if it's equal to, we're going to include that line in our solution. Therefore, when you graph that line, you want it to be a solid line to indicate, yes, everything on this line is included in my solution. If it's just a less than or greater than, then you're going to use a dotted line, and that indicates, okay, you're going to come up to this line, but you're not going to include this line. Everything up to there, but not anything on the line, okay? So make sure that that is part of your solution, is whether that line is solid or dotted. All right, so to solve systems of linear inequalities, there's more than just the line involved here. So the first part is the line, and so step one is to graph both lines on the same graph, being careful to watch, is it solid or dotted? Okay, do you have that little line underneath indicating equal to? Once you have your two lines, your lines indicating, okay, these are the boundaries, because it's because we're including other points on the graph, you're going to test a point on the graph, anywhere on the graph, to determine which side to shade. Okay, I think you've done this before, that's why I'm kind of moving quick. But let's do some. We're going to do a couple, and I'll show you what I mean by testing a point and shading. Okay, so with our first one, the first thing you're going to do is you're simply going to graph the line itself that indicates the boundary. And when you do that for just a minute while you're graphing it, you're going to ignore the symbol, the greater than or less than, the inequality symbol. Just ignore it and pretend in your head that it's an equal sign for a little while, okay? We're going to graph this exactly the same way that you graphed a line. Several of you find that it's easier to use the x and y intercepts, so let's do this first one that way. So x plus 2y is less than 6. So in your brain, you're just thinking, okay, x plus 2y equals 6. So the x, if you cover up the y, the x-intercept is going to be 6. So x is right and left. So we're going to go to the right because it's positive. 1, 2, 3, 4, 5, 6. And this line is going to cross the x-axis right here. All right. And then you're going to cover up the x. So 2y equals 6. To get just y, and you can do this in your head or you can do it on your paper, either way. So 2y equals 6, so you're going to have to divide by 2. So y is 3, and y, remember, is up and down. So you're going to start at your origin, and because it's positive, you're going to go up 1, 2, 3, and there's your second point on your line. Now at this point, you're going to draw a line, but at this point, pause and go back to look to see, do we include this line or not? There is not an equal, so this line is not included in our solution. I'm looking for a straight edge. I wonder if I have one easily accessible. Oh, looky here, I do. All right. So line up your point, line up your 2 points, and you're going to make this one dotted. All right, so whoop. There's your dotted line. So that's the first one. And then you're going to look to see, okay, now this is the part where you're going to test a point to determine which side of this do you shade it. And honestly, the order that you do this doesn't matter, but on my steps, I told you to graph both. So let's do that first. So second step then, or second part is you're going to graph this line. So cover up the y. The x-intercept is 2x equals 2. Divide both sides by 2, so x is 1. So x, whoops, there's my origin. X is 1. And now when we cover up the x, negative y equals 2. So therefore we divide both by negative, and so y is negative 2. So negative 2 goes down 2. And now before you graph it, pause. And my inequality is greater than or equal to, so this one is going to be a solid line. So line it up and then make your solid line, and yours should be easier because you don't have a great big thick marker you're working with. All right, so now on these lines, because this is not exactly on the line, your solutions are also anything that is less than, anything that makes this statement less than 6 is also included. So what you're going to do is go back to your original line, and you're going to say, okay, so on this line, I always just pick the point 0, 0. Pick the point 0, 0 and say, does the point 0, 0 correctly solve this equation? So you're going to put in 0 for x plus 2 times 0, 0 for y, is that less than 6? So 0 plus 0 is 0. Is 0 less than 6? 0 is less than 6. So if this point makes your statement true, then you're going to shade everything on this side of that line. Don't get confused with the two lines, okay? So far, so good? If that had not been true, we would have shaded the other side, okay? So now let's go to the second inequality, and we're going to test the same point just because 0, 0 is easy. As long as your line doesn't go through 0, 0, just pick 0, 0 every time. So 2 times 0 is 0, minus y is 0. Is that greater than or equal to? Is 0 greater than 2? No, 0 is not greater than 2. So here's my point. 0 is not greater than 2, so this side of the line is not going to get shaded, which means the other side of the line will get shaded. So everything over there gets shaded. So now my solution is where these lines cross. So everything in this triangular area is the solution to my problem. So what this means is anything in this area of the graph, any of those points, if I put in the x and the y for that point, then both of these statements will be true. I can pick any point on the graph in this area, and it'll make both of those statements true. Okay? You start on the next one while I'm erasing things and getting set up again. So start on your first one. You're going to graph it first. You're going to graph your two inequalities. All right. So when you're graphing this one, and let's do these in the y equals mx plus b form, okay? Just to give equal access, don't you know? Okay, so y equals mx plus b. So my b is going to be 0 in this case. So it's going to, my line is going to cross the y-axis at the origin. So there's 1 point. And the slope is the number in front of the x. So that's a 1. So 1 is the same as 1 over 1. So you're going to go up 1 over 1 and make a point. And if you want to do a couple of them, you can. And then once we have a couple of points, now we pause. We go back and we look. There is no equal to. So this line is going to be dotted. So dotted line. Oh, my marker is dying. I'm going to have to get a new one before the next video. Okay. Now your other line. And let's do that one. Let's do this line. Also in mx plus y equals mx plus b form. So we're going to add the y to both sides. So y is over here. Y plus 4 is less than or equal to 3x. So let's subtract the 4. So 3x minus 4 is less than or equal to y. So now here's your mx plus b. So your b is your y-intercept. That's your negative 4. All right. So we're going to go to negative 4 in up and down on the y. So start at the origin and 1, 2, 3, 4. There's your There's your y-intercept. And now the m is your slope. And that's the number right in front of the x, which is a 3. So 3 is the same as 3 over 1. So remember, the slope is rise over run. So from here, we're going to go up 3, 1, 2, 3, and over 1. And you can do it twice if you wish. Oh, look, there's the crossing point. All right, and now, oh my goodness, I need a longer ruler for this. Oh, wait, pause. I was making him dotted. Is that right or wrong? Let's go back. Oh, looky here. This one is equal to. That would have been wrong. We want a solid line on this one. We want a solid line. My line is dotted just because my marker is dead. Yeesh. Okay. Now, last thing. We're not done yet. Now we have to shade. So here's a case where on this one, whoa, this first line, going back to our first line, I said I always pick 0, 0 because it's easiest. But if you look here, 0, 0 is on the line. So that doesn't help me. Of course it's going to be true. It's on the line. That doesn't help me know which side to shade. So pick any point you want. There's a whole area up here that doesn't have any points. Let's just say 0, 1 would be this point here. So x is 0 and y is 1. So 0, 1 is up here. Is 1 less than 0 is what we're asking ourselves. Is 1 less than 0? No, 1 is not less than 0. So I can't shade the top, I shade the bottom. So all of this is shaded for that one. So below that first line. Now we're going to look at the second line. And that one I can put in 0, 0. That makes my life easier. So 0 minus 0 is 0 minus 0 less than or equal to 4. 0 is less than 4. So I'm going to shade everything above this line. So it's on this side. So I already know. So it's going to be on this side. So it's everything here on this side. So I know my solution now is what's in between these, because that's going to be where they cross. All right? Make sense? So this time I didn't shade all of it. I just shaded the solution area. So everything from this line, everything over this way is a solution to this line, but the solution to my system is just what's in between here. So that's the part that matters. Okay? All right. So it's easy to do once you understand the process. You're trying to find points on a graph that make two inequalities true. You're going to do that simply by graphing both of the inequalities, graph the line that they represent, being careful to know, is this a solid line or a dotted line? Once you've plotted those lines, then you just test one point and see, does this make this inequality true? If it does, then you shade that whole side of the graph. If it doesn't, then you shade the other side of the graph. You don't even have to test another point. Then you go to the second inequality and you test a point on one side or the other of that inequality. And the places where those shaded parts cross, that is your solution, that part of the graph. Every point in that part of the graph is a solution to your system of inequalities. All right, see you next time.